part one of this network troubleshooting series, we looked at the basic tools you need to equip yourself with and introduced you to some common techniques to help you troubleshoot your SDVoE network efficiently. This course will take a closer look at the type of networking issues which would affect the performance of your SDVoE system and use networking tools we introduced you to in the last course to show you how to approach these problems in a logical manner. Now that we've familiarised ourselves with a typical interface from the troubleshooting software, let's take a closer look at some of the most common network problems which can occur with video distribution. The first being a network loop. SDVoE receivers often include a 1 gig network port for attaching other devices. Now, if this port is somehow connected back into the switch, a network loop will be introduced and that will shut the entire network down. Remember, the 1 gig LAN port is designed to be a useful utility to connect hosts locally adjacent to the receiver. But under absolutely no circumstances must this port be connected back into the same network which is providing the stream. If the network appears to be frozen, disconnect anything connected to the 1G ports, and if everything comes back online, the problem points to a network loop. The next issue that you might face is devices not being detected on your network. You open the control software after powering everything up, and some devices do not register in the API as expected, which means they aren't showing up on the user interface. Let's head over to our troubleshooting software again to see what's happening. Earlier in the course, we looked at the UDP packets which are being broadcast over the network by the endpoints. We know that they're broadcasted because of the destination IP addresses used. Every host on the network will receive these packets, and we often refer to these discovery packets as hello packets. These discovery packets can either be shown from the 169.254 IP scheme we see here, or they could come from the 192.168 IP scheme if there's a DHCP server on the network, for example. If the devices don't appear at all, this often points to either bad cabling or the switch configuration preventing your endpoints from being on the same LAN. And these will need to be checked before any more debugging takes place. If your network infrastructure is in good shape, then it's highly likely your endpoint has been assigned an IP address which is outside of your network domain. And the quickest solution in this case is to reset the endpoint to factory defaults, which will then tell it to use DHCP. If that isn't an option, you could manually change the IP address of the missing device to match the network subnet, or alternatively temporarily change the IP settings of your controller to that of the rogue device to allow you to access it and then get it back to the correct subnet. Another possible problem is that no video is displayed. If none of the displays are working, it's highly likely your network switch has either not been configured for IGMP or you haven't disabled flooding, or both. It's time to introduce you to the 4 commandments, the 4 essential network switch rules required for any SDVoE system. SDVoE relies on a 10 gig network to match the performance of a matrix switch. Your 10 gig network switch must be configured for IGMP v2, which includes enabling IGMP v2 snooping and IGMP v2 fast leave. Now, you'd be hard pushed to find any 10 gig switch out there which doesn't support this. However, in many cases it probably won't be enabled by default. Finally, it's really important to disable any unregistered multicast flooding, which will prevent the switch from broadcasting any multicast packets which are not required by an endpoint. If your switch broadcasts unregistered multicast traffic, that means it'll be turning our high bandwidth but targeted multicast streams into broadcast streams, and that huge bandwidth signal will go everywhere, freezing your entire network in seconds. If you're confident enough with your troubleshooting software, you can double-check your switch configuration by connecting your laptop to the switch using an external 10 gig interface if your computer supports it. This interface will allow you to monitor video streams from an endpoint. However, if it doesn't, you can set your endpoint to only stream audio and use an audio streaming application on your computer like VLC to join the multicast group of the endpoint. And that'll allow you to visually see the multicast traffic to that group. This might take a bit of practice, but once you've mastered it, it'll prove invaluable to any future troubleshooting that you might need to do. Finally, if you move an SDVoE endpoint to a completely different network, it's always good practice to factory reset the device first, and you should consult the manufacturer's documentation to help you to do this. Not doing it could result in the new system not working as expected, because the device may be trying to use old multicast addresses, which are conflicting with the new system. And while the API is able to work around this, you might find the receivers are displaying multiple overlaid ghost images. Factory resetting the device first will ensure any address history is erased completely. SDVoE is designed with reliability in mind, but this should not lead to complacency. Basic networking know-how and having the correct tools are essential for finding and resolving any networking issues efficiently. Please don't just guess your way through it, because it simply doesn't work. Between the resources available here on Academy and the support available from your manufacturer, you have all the help you need.